All right, IM3 classes. Today we are moving on to the next module. We're talking about adding and subtracting rational expressions. Rather, we're not talking about adding and subtracting rational expressions just quite yet. We're building to that. We're going to start with simplifying, and then we're going to multiply and divide, and then we'll get to adding and subtracting. But it's all part of this. Today we're just going to be simplifying and talking about excluded values. Rational expressions, real quick before we get to there. We talked about what rational numbers are in the last unit. Rational numbers are numbers that can be expressed as a fraction. So all whole numbers and all fractions are rational numbers. So rational expressions are expressions, so that can be expressed as fractions. So this includes, just polynomials on top of each other, that sort of thing. So we're working with polynomials. We're going to be factoring again, all that good stuff. But within fractions. So starting off, rational expressions, fractions of polynomials, just like I just said, there's an example there. First thing we're going to be doing is finding the excluded values. The excluded values is where the expression is undefined, meaning the values in the denominator would be, or wherever the denominator is equal to 0. So to find excluded values, you take the denominator, say it equal to 0, and solve. And then those will be the excluded values. So more practice with factoring and solving. So we're going to take that example here to find the excluded values. Set denominator equal to 0. So the denominator is the bottom of the fraction. So x squared minus 14x plus 48 is equal to 0. And then we factor and solve. That's an ugly 0. Factor and solve. For this one, 48 on top, negative 14 on bottom. Factors of 48 that had negative 14, that's going to be negative 6, negative 8. So the factors are x minus 6 and x minus 8. Remember from the last unit, to solve that from there, use the zero product property. You set each factor equal to 0 and then solve. You're going to add 6 over here, solve this one over here. I'm going to just do it real quick so I don't have to keep getting the green one in and out. But this one, x is equal to 6. Over here, x is equal to 8. So these are the two excluded values at those parts in the function. That's where the function is undefined. Remember, you can't divide by 0. This is where that function is going to be equal to 0. So it's undefined there. Let's do another one. Find the excluded values. Again, pretty simple on this one. Take the denominator, set it equal to 0. Not a whole lot to solve on this one. There's no factoring. Divide both sides by 28. 0 divided by anything is just 0. So the only excluded value is 0. This one here, so we have 5x plus 25 is equal to 0. You can just actually, this one, you could factor out of 5. It's not necessary to solve. So just take the denominator, set it equal to 0, and solve. So the last step here, I'm going to divide by 5. Get x is equal to negative 5 is the excluded value. Next one, take the denominator. I'm going to take that. I'm actually going to, instead of writing it out there, I'm going to factor it first. So it's be 12 and 8. Factors 12 that add to 8, that's going to be 2 and 6. So the factors for the bottom are x plus 2, x plus 6, and then I set that equal to 0 and solve. So it's x plus 2 is equal to 0, x plus 6 is equal to 0. Subtract from both sides, you get x equals negative 2. Subtract 6 from both sides, you get x equals negative 6. I should show my work. Subtract 6 over here, so we're subtracting 2 on this one. So the two excluded values, negative 2 and negative 6. All right, so finding excluded values, pretty simple. What we're going to do now is simplify these. So a lot of factoring going on. What you want to do when you are doing this, you're going to factor the top and you're going to factor the bottom. So first step, simplify. Let me back up a second. Simplifying rational expressions is just like reducing fractions. That's all we're doing. We're finding common factors in the top and bottom and they cancel each other out. So I'm going to factor the top. Real easy, I can factor out a 9n on the top. And then I am left with n plus 9. So remember, when you're taking stuff out, that's just reverse distributing, undoing the distribution property. I need an x factor for the bottom, so negative 18 and 7. Factors a negative 18, that is 7, that's going to be positive 9, negative 2. So factors on the bottom are going to be x plus 9 and x minus 2. Here's my favorite part of it. You look for common factors. Anything that's in the same in the top and bottom. I don't know. I got to make sure I keep in track of their n's, not x's in this problem. Now things match. N plus 9 on top and bottom, those cancel each other out. And then I'm just left with n, 9n over n minus 2. Here is a common mistake I see a lot. So this is the answer. This right here, n, 9n over n minus 2. Common mistake I will see over and over again is once kids have it 9n and n minus 2, what they will do is cancel this out. You can't do that. This n is protected by the parentheses. It's not a factor. It's part of its own. This n up here is a factor. If there's another n on the outside, we could do that. But this, right? So kids will say, oh, it all simplifies down to 9 over negative 2. This is not no good. Don't do that, right? The n, since this n is inside the parentheses, it is protected. It doesn't cancel out. It'll only cancel out if there was an n minus 2 on top. All right, so let's do another example. Factor the top. So I can take out a 2x on top, and I'm left with an x minus 5. I need an x factor for the bottom, 15, negative 8. Factors 15, add a negative 8. That's going to be negative 3, negative 5. So x minus 3 times x minus 5. And look at that. I have x minus 5s that cancel out. So this simplifies to 2x over x minus 3. Next one, I need to factor the top. So 2 times 10 is negative 20. 1 on the bottom factors negative 20, that adds to 10. That's going to be negative 4, positive 5. Don't forget to divide. Since we multiplied by 2 to get the top, we have to divide out that 2. So we get negative 2. So the factors on top are going to be x minus 2. And then this one is 2x plus 5. On the bottom, I can factor out a 2. So 2 times x minus 2. And here, those cancel out. I want that to be in red. X minus 2 cancels out. So left over on top, 2x plus 5. And then over 2. Remember, these 2's do not cancel each other out. This 2 is protected by those parentheses. It's not its own factor, so you can't cancel it out with the 2 on bottom. Another example. Yeah, I'm looking at this, it's like, but this is going to have a couple layers of factoring, at least on the top. So, yeah, I'm going to write this over the side. So 9k squared plus 45k plus 36. Those are big numbers, but if you look 9, 45, and 36, those are all factors of 9. So I can take out a 9. I get k squared plus 5k plus 4. And then if I do an x factor with what's left over, I have 4 on top, 5 on bottom. That's going to be 1 and 4. So this whole thing on top factors to k plus 1 times k plus 4. Again, don't forget the 9 on the outside. So the top is 9 times k plus 1 times k plus 4. Now the bottom. I need an x factor for the bottom. So 5k squared plus 22k plus 8. that over a little bit. This does not have everything in common, so I need to multiply 5 times 8 is 40. 22 on bottom, factors of 40 that add to 22 would be 2 and 20. Since we multiplied by 5, we have to divide out the 5, so that's 4. So this factors to 5k plus 2 times k plus 4. I should just use x's. These k's, I don't know. I don't like them. Whatever. 5k plus 2 times k plus 4. Now cancel out common factors. K plus 4 and k plus 4 are gone. So I'm left with 9 times k plus 1 all over 5k plus 2. Whew. A lot of factoring going on in that problem. All right. Sure. All right. The top factors, pretty easily just factor out a 3 at the top and bottom. So 3 times 3m plus 10. Bottom is going to have a few more layers. I can factor out a 3 on that one. So 3m squared plus 1m minus 2. And then I need an x factor for the rest of that. So 3 times 2 is -6, 1 on bottom. Factors of -6 add to 1. That's going to be +3, -2. Don't forget, since we multiplied by 3 to get the top, we got to divide it back out. So this reduces to 1. My factors would be 3 times m plus 1 times 3m minus 2. So on the bottom, 3m plus 1 times 3m minus 2. Doesn't look like much, but the 3's on the outside cancel out. And that is all. Nothing else matches, so it's just 3m plus 10 on top. All over m plus 1. And I think that will do it. It's probably plenty of examples. So just remember, back to the top, back to the bottom, cancel out common factors, and you are done. All right. We will see you guys next time when we will be multiplying and dividing rational expressions.